So how we can find the norm of a vector? We have a formula that what is basically the norm. First, we have to know about this one. What is norm and how we can find a norm of a vector, okay? So norm of a vector, how you can define it. The distance between, the definition is that the distance between the initial and terminal points of a vector V is called the length, you can say, okay, the magnitude, you can say, or you can say the norm. Okay, so they have the same words, same name. So either you can say the length of a vector, it's the same formula, the magnitude of a vector is the same formula, the norm of a vector is the same formula. Okay, so magnitude or norm of V, and it is denoted by, it is denoted by norm of V like this one. Okay, so if you have any vector V, V is a vector that have the coordinates v1, v2, and v3. The norm of a vector, the norm of a vector V is equal to square root of v1 square plus v2 square plus v3 square. Okay, so from this formula you can easily find the norm of any vector. It is given to you, you can easily find the norm of the vector. Now I'll give you one example that how you can use this formula to find the norm of a vector. Okay, for example, find norm of A is given, which is V, which is equal to 2, 3, and 6. Okay, and B, you have to find the norm of vector 5V, and the third one, C, you have to find the norm of 2V minus 2V. Okay, so solution. So vector V is given to you, which is 2, 3, and 6. You have to find the norm of a vector. We know that norm of a vector is equal to what? Write the formula v1 square plus v2 square plus v3 square. Okay, so if I substitute the values, what I will got? Square root of 2 square plus 3 square plus 6 square, which is equal to what? 4 plus 9 plus 36, which is equal to square root of 49, and 49 means 7. Okay, so we have norm of a vector V is equal to what? 7. So this is A. Now come towards B. We have to find the norm of, norm of 5V. Okay, so 5V norms can be represented as 5V norm like this one. Okay, so you can write this is equal to 5 outside and norm of V. And norm of V, we already calculate that is equal to what? 7. So 5 multiplied by 7, that is equal to 35. Got it? Understand? Similarly, you can find the norm of minus 2V. See, the norm of minus 2v can be written as like this one. So this is equal to minus 2 mod of v, which is equal to 2 times norm of v, and 2 times norm of v is 7, so that is equal to 14. So why you didn't take the negative sign? Because for the negative sign is for only for the direction, okay, not for the magnitude. So it means that whenever you have any number with the vector v, so that you can write the mod of that number and the norm of the vector v. Mod means what? Mod means if you have a negative sign, it will be positive. If you have positive sign, it is automatically positive. Okay. So that's why we take the mod of the negative 2. So that is equal to 2. So that will give you 14. Okay. Understand? Now this is about the norm of a vector. Now we talk about the unit vector. Maybe you studied about the unit vector, how you can find a unit vector. Unit vector is what? A vector of length. For example, you say the length or the magnitude or the norm is equal to 1 is called the unit vector. Okay. Is called the unit vector. In three spaces, in three dimension, okay, if we talk about in three dimension, the unit vector along x-axis, y-axis, and z-axis can be represented as or denoted by, anybody know what are the unit vectors for x, y, and z? I, j, and k respectively. Okay, so this is the notation of the unit vectors. For example, if you have the any x, y, z three-dimensional case, that is x, that is y, and this one is z. Okay, so in the same direction of x, in the same direction of y, in the same direction of z, you will find the unit vectors. Okay, for the dimension of x, that means the y and z is 0. So that means you will got the dimension unit vector for the x component, that is I. Similarly, for the y, you will got j. Okay, and for the z-axis you will got k. So how you can represent the I, j, and k? So I vector is basically is equal to 1, 0, and 0 because it is a unit vector. So you can calculate the unit vector, that is 1 square plus 0 square plus 0 square, that is equal to square root of 1 square, which is equal to 1. So its length is 1, so that means this vector is a unit vector. Okay, so this vector is a unit vector, so you can represent that one is equal to the unit vector of x quadrant. Okay, because here y and z is 0. Similarly, you can find the unit vector for the y quadrant, that is 0, 1, and 0. It's also the length of this vector is 1, and the same for the z-axis, the unit vector is 0, 0, and 1. And for all these cases, for all these three vectors, the unit vector, the length of these vectors are equal to 1. So every vector, whatever is the vector, there must be one unique representation of unit vectors. Okay. For example, if I choose a vector v, let me explain in detail with you. For example, a vector v, you have the representation v1, v2, and v3. Okay. So how we can represent is expressible uniquely in terms of I, j, and k as follows. Okay, how we can represent, for example, v is a vector that have the coordinates v1, v2, and v3. Can I write v1 is equal to v1, 0, and 0? And for the v2, I have to write 0, v2, and 0. For v3, I have to write 0, 0, and v3. If I add these three vectors, I will definitely get this vector. Okay. So v1 is a coordinate, is a number. So you can take outside, that becomes 1, 0, and 0, plus v2 you can take outside, that becomes 0, 1, and 0. Similarly, for the v3 you can take outside, that becomes 0, 0, and 1. And we know that 1, 0, 0 vector is the I vector. Okay. And v2, 0, 0, 1 vector will be the j vector. And v3 vector, that will be the k vector. So this is the unique representation of the vector in terms of the unit vectors. Okay. So v vectors you can represent in this form. Got it? So these are the general notations. So I will explain each and every detail of the vectors with the definitions. So maybe when we solve the examples, you will not find any difficulty. Okay. So now the next one is the normalizing of a vector. Okay. How we normalize any vector. Normalizing a vector. How we can normalize? Okay. So there is a definition. The process of multiplying I think the charge of the pen is very low. The process of multiplying a vector v by the reciprocal of its length to obtain a unit vector with the same direction is called normalizing vector v. Okay, so what is meaning of this definition? That multiply if you multiply any vector v by the reciprocal of its length. Reciprocal means, for example, you find the length of the vector v, which is equal to, for example, 7. 7 is the length, and the reciprocal of this one means 1 over 7. Okay. For example, you find any vector, it's for example, that is equal to the length is 1 over 3. 1 over 3 is the length. For example, you find. Okay. So The reciprocal of 1 over 3 is 3. Okay, so you have to multiply with the reciprocal of the length to the same vector, you will find the normalization. Okay, first find the length. Whatever is the length you find, just make the reciprocal. If you find the length, for example, that is equal to 4, the reciprocal is 1 over 4. Then you have to multiply 1 over 4 with the vector, you will get the normalization. Okay, so for example, I will give you one example so it will be very clear. See, find the unit vector, find the unit vector that has the same direction as you have the vector v, which is equal to 2i plus 2j minus k. Okay, minus k. Okay, so what is the first step we have to do? What is the vector? Vector v is given, that is 2i plus 2j minus k. You can denote this into the component form. The component form of this vector is 2, 2, and minus 1, right? Is this okay? That means you have the v1, v2, and v3. So how you can find the norm of the vector? Norm of the vector, we have a formula that is equal to v square v1 square, v2 square plus v3 square. Okay, so that will becomes what? 2 square plus 2 square plus minus 1 whole square, which is equal to 4 plus 4 plus 1, 9, square root of 9, that is equal to 3. So the norm of the vector v is equal to what? 3. Okay, the reciprocal, the reciprocal of the length is equal to what? Anybody can tell me? The reciprocal of the length implies what? 1 divided by 3. Okay, Abdullah, this is the length. The reciprocal will be 1 divided by 3. Okay, now what you have to do? You have to multiply this reciprocal with the number. So the unit vector, u in the same direction as v, which is equal to what? U unit vector is equal to the reciprocal of the length, which is 1 over 3. You have to multiply with the vector. Okay, so 1 over 3, what is the vector? Vector is this one, that is 2i plus 2j minus k, that is equal to what? 2 by 3i plus 2 by 3j minus 1 over 3k. So this vector is the normalized vector. Okay, so we normalize the given vector into this form. So this and this have the same direction. Okay, got it? So what we have to do? We have to just first find the length, which is very easy. Then you have to take the reciprocal, and then reciprocal you have to multiply with the vector, and which vector you will got it, this is the normalized vector, and this is also a unit vector. Okay, so is this a unit vector or not, we have to check. Okay, see, remember this vector, which is what? That u vector is equal to 2 by 3i plus 2 by 3j minus 1 over 3k. Okay, So I can represent this one in the form of the vector representation, that is 2 by 3, 2 by 3, and minus 1 over 3. And we have to check that this is the unit vector or not. Okay. For checking the unit vector, that means it should uh, you should have to find the length of this one. So length of this one, we know that v1 square, v2 square plus v3 square, which is equal to 2 by 3 whole square. You can't listen, Hamad. 2 by 3 whole square plus 2 by 3 whole square plus 1 minus 1 over 3 whole square. Okay. Simplify it. What you will get, 2 by 3 whole square means 4 over 9 plus 4 over 9 plus 1 over 9. Okay. You simplify it, you will get 9 divided by 9, which is equal to square root of 1, which is equal to 1. So this means the length of this vector is 1. So it means this is a unit vector. Got it? So this is how to check that the vector which we got from the normalization, it must be a unit vector. Okay, this is must. No, this you don't need to do in the exam. Okay, this is for the check that what we got is it's a unit vector or not. Okay, so if you check your answer, it's right. So you can check by yourself like this one. From this one, you can find, yes, what I find, it's very correct. Okay, so no need to do these steps when it is not asked. If in the question it is written that you have to check that this is a unit vector or not, then you have to do this one. If it is not written, no need to do this one. Okay, got it? If equal to 1, it's a unit vector. Yes, equal to 1, it's a unit vector. If it is not equal to 1, it's not a unit vector. So it means there must be some mistake in your calculation in the example.